rather than focusing on the hypothesis that an effect size is equal to 0, as the null hypothesis does. Estimation methods use statistical procedures to combine two estimates of the effect size. One is an exact point estimate, and the second is an interval that includes a range of values that likely contains the population value of the effect size. Most ideas about using estimation methods do rely on confidence interval procedures, which are of course based on null hypothesis testing procedures. However, the emphasis for estimation methods is shifted to provide a richer context for interpreting a point estimate of an effect size by accompanying it with a confidence interval, as shown in the two examples here. A confidence interval provides a way to make a decision about a null hypothesis if the interval includes an effect size of 0, as in the example on the left, then the null hypothesis is retained. But a confidence interval for an effect size also communicates information about the variability in the data, so that rather than making a decision about statistical significance, the researcher is able to consider more information and use the confidence interval as an estimate of the possible range of effect sizes, smaller intervals obviously being preferable to larger ones. When inspecting a graph like this, it is important to determine what the interval represented by the error bars represents. It might be a 95% confidence interval, or a 90% confidence interval, or it might simply be a standard deviation, a standard error, or some other measure of variability. If the interval is a confidence interval, it is also important to remember that these intervals do not indicate the probability that the true effect size lies within the interval. They do give you a representation of the variability in the data and the size of the sample, because both of these factors figure into the size of the confidence interval. Researchers who encourage the use of estimation methods often also advocate the use of more advanced graphical methods. For example, this estimation graphic, as it is called, compares the scores of participants in a control group and a treatment group. The label C in the figure indicates the control group. T indicates the treatment group. The left-hand vertical axis depicts the dependent variable. The right-hand vertical axis shows the difference between the means of the control and treatment groups, with the 0 point marking the mean of the control group. The single point over the T-C label marks the mean of the treatment group. That point is accompanied by a bar that marks the 95% confidence interval and a sideways normal curve that represents the estimated sampling distribution for the treatment group mean. The estimation graphic shows every data point, which allows the reader to inspect the data set for outliers and other patterns, and includes summary statistics like the mean and a 95% confidence interval. The main point is to notice how the emphasis in the graph has been shifted away from the null hypothesis, which would be an effect size of 0, indicated on the y-axis on the right side of the graph. The emphasis here and in any other estimation method is on the size of the treatment effect, which is indicated by the Greek letter delta.